All right, example 2 is something we've done before. It is basically solving a quadratic equation. So this is not the example out of the sections 5.2 and 5.3. I want to do this first where we go back and look at something out of the quadratic formula. That way it will help you easily pick up the idea for the question in sections 5.2 and 5.3, okay? So let's go ahead and do this first, and then I will explain the problem you need to know, okay? All right, so example 2, nothing more than using the quadratic formula here, solving a quadratic equation. Solve the equation for x squared plus 2x plus 2 equals 0, okay? This is quadratic, highest power of x is 2, okay? In order to solve a quadratic equation, it's got an equal sign, so you can solve for x. You can either factor or use the quadratic formula. Okay, I'm going to use the quadratic formula here, but remember, either direction you go, in order to start, you need to have one side equal to 0, which we already do. Okay, so we can go ahead and identify our a, b, and c. A is the number in front of x squared, it's 1. B is the number in front of x, it's 2. C is the constant, also 2. Okay, we're going to plug and chug this into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let's go ahead and plug these values in. Okay, so our x values are going to be negative 2 plus or minus the square root of b squared, so 2 squared, minus 4 times a times c all over 2a. Okay, and now we're going to simplify this. Okay, always start with what is under the square root. Okay, so we're going to get negative 2 plus or minus the square root of, let's see, we've got 4 minus 8 all over 2. Okay, continue up here. Okay, so we're going to get negative 2 plus or minus the square root of negative 4 all over 2. Okay, and at this point, you immediately, from what we've done in the past, back in section 4.3, 4.5, chapter 4 in general, if you see this negative under the square root, you say, okay, there's no solution. Okay, and we stopped. Okay, remember what this meant. Okay, if we were to graph this guy out, okay, it wouldn't have any x-intercepts. Okay, that's why, you know, basically to solve for an x-intercept, you take your quadratic, set it equal to 0, you solve. Okay, and getting a negative underneath the square root tells you there's no x-intercepts. Okay, we're going to take it a step further. Okay, like I said, chapter 5 starts getting into imaginary numbers. Okay, that negative under the square root is indicative of an imaginary number. Okay, what you need to know about imaginary numbers, and maybe you already know this from your past, I is defined as the square root of negative 1. Okay, that is the imaginary unit. Okay, so I is the square root of negative 1. Okay, all right, so what I'm going to do here is I'm going to rewrite this as negative 2 plus or minus the square root. Okay, under the square root, I have negative 4. Negative 4 is the same thing as negative 1 times 4. Okay, so that's the same thing. I just wrote it a little differently. Okay, then there's a rule of square roots that you may not be familiar with, but you can break this up. Okay, this is negative 2 plus or minus the square root of negative 1 times the square root of 4. Okay, they can't both be negative because negative 1 times 4 gives you negative 4. Negative 1 times negative 4 would give you positive 4. Okay, so you can write it this way. Okay, the bottom is still 2. Okay, and then if we keep going, this is going to be negative 2 plus or minus the square root of negative 1 is I. So I times the square root of 4 over 2. Okay, this is negative 2 plus or minus the square root of 4 is 2. So this is going to be 2i. 2i, you could write it I times 2 or 2 times I. It doesn't matter. Okay, everything is divided by 2. So you got to divide both pieces by 2. Okay, and so the final answer would be negative 1 plus or minus I. Okay, these are the imaginary, okay, we don't have any real x-intercepts. We have imaginary x-intercepts, okay? Like I said, if you were to graph this on your calculator, okay, your parabola would be completely above the x-axis, okay? There would be no x-intercepts, okay? No real x-intercepts. There are imaginary zeros, okay? They don't appear on the graph, okay? All right, what I need you to realize here is you got two zeros, okay? You got the plus version in the middle and the minus version in the middle, okay? These things, okay, so let me write them out. Get rid of this page number because it's in our way. All right, so the solutions are, okay, we got -1 plus I and -1 minus I, okay? These were the two solutions, imaginary solutions to this quadratic equation that we have, okay? These guys are something called conjugates, okay? And that's a fancy name, and what it means is, okay, for both of these are the two different solutions. They're different. I picked the plus in the middle over here. I picked the minus in the middle over here, okay? What conjugates means is they're basically the same thing. Like the left side is -1, -1. The right side is I, okay? The difference is the sign in the middle, okay? So this sign right here, okay? So they both have the same thing on the left, the same thing on the right. The sign in the middle is what's different, okay? And that makes them conjugates. They're the same thing, but they have a different sign in the middle, okay? So the reason I did this example is to tell you how imaginary zeros work. They come in conjugate pairs, okay? So I'm gonna put that right here, okay? So imaginary zeros come in conjugate pairs. Always, not just for quadratics, okay? With the stuff with polynomials of higher degree, okay? If you get imaginary zeros, they're going to come in conjugate pairs, okay? Meaning, if you were solving something and you got this guy as a 0, -1 plus I, you also have to have its conjugate pair as a 0, -1 minus I. They have to come in pairs. You can't have one without the other, okay? And again, this applies not only to quadratics, but also for polynomials of higher degree, okay? So the last type of question you need to know, okay, is over here, okay? Above question number 3 is the conjugate pairs theorem, okay? All that's telling you, okay, is that your zeros, if they're imaginary, they have to occur in conjugate pairs, okay? That's what I just told you, okay? All right, so here's a question. This is the last type of question you need to know for the final, okay? This is a multiple choice question, okay? You are given basically a function of a polynomial of a higher degree. This is degree 3 here, okay? And you're also given one of the zeros here, okay? The question says use the given 0 to find the remaining zeros of the function, okay? So you are given this polynomial function, okay? You are told that one of the zeros is 1 plus I. That's an imaginary 0. So if you graph this thing on your calculator, you can't see it. Imaginary zeros don't show up on the calculator or any graph, okay? So you have your options listed here, which will help, okay? So the thing is, if you have a polynomial, it can have both imaginary zeros and real zeros, okay? Zeros, same thing as x-intercepts. So you may see a physical x-intercept on the graph. That's going to be your real x-intercept or your real 0, okay? But if they're imaginary, they won't show up, okay? All right, so first thing you need to know, this is an imaginary 0, okay? By the conjugate pairs theorem, okay? Since this is a 0, they have to occur in pairs. So you're going to leave the left side the same, 1. You're going to leave the right side the same, I. You're going to change the sign in the middle, okay? So this has to be one of the other zeros, okay? Again, no way to tell this on the calculator, okay? So multiple choice, okay? What can I eliminate? Well, option D, gone, okay? It doesn't have a 1 minus I. The other guys do, okay? So the question becomes, how do I find the other 0, okay? Well, to be honest, you can put it in your calculator, okay? You know that if something's a 0, it's going to appear as an x-intercept, okay? So if I were you, all I would do is pop this thing into the calculator and graph it, okay? The function is x cubed plus 5x squared minus 12x plus 14, okay? Use that 10 to 10, negative 10 to 10 window that I always show you, okay? And there you go, okay? Remember, we set the scale equal to 1 in both directions, so every tick mark is 1 unit, okay? Here is the other physical x-intercept right here. It's at -1, -2, -3, -4, -5, -6, -7, okay? So it looks like the other 0 is at -7, okay? So this is going to be the correct answer, okay? This one is not true because the 0 is, it's asking for zeros, not factors. Keep that straight. +7 is not the 0 or the x-intercept. It's -7. And then this is not correct. This is a different imaginary number, okay? You can confirm -7. Remember, you can plug it into the function, okay? If it is an x-intercept, you should get 0 as the output. So you can do that to check if you wanted to, okay? It suffices to just look at your calculator for this, but I'll go ahead and show you that this does work, okay? Plug -7 into the function, okay? You should get an output of 0 to confirm that that is an x-intercept. So let's do that real quick, okay? Hopefully you can see that. -7 cubed, -7 has to be in parentheses to take care of that negative appropriately. Plus 5 times -7 squared minus 12 times -7 plus 14. Boom, you get the 0. So it is confirmed that -7 is a 0, which is an x-intercept. Okay, so answer A would be the correct option. Okay, the big thing to remember for these imaginary zeros, you cannot see them on a calculator and they come in conjugate pairs. Okay, which means you leave the left side alone, you leave the right side alone, you only change the sign in the middle. So if this is a 0, this has to be a 0. If this is a 0, this has to be a 0. They come in pairs, okay? You may also have a real 0 associated with it as well, okay? Thanks for a really good semester. I know it's been really hard for all of us, okay? But you guys have really persevered and stuck with it, okay? And I'm really proud of you, and you're going to ace this final, okay? So good luck on it, and let me know if you have any questions, okay?